Welcome to part 3 of the GoPxL first-time user video series. This first-time user video will help you get started using GoPxL on a G2000 series profile line sensor, introducing some basic measurement tools and interface tips. To get the most out of this video, download the following files to be able to follow along. Measurement Tools Sample Exercise 1. Scans from G2000 sensors. This will get you familiar with how GoPxL measurement tools work, as well as demonstrate how to control the inputs and outputs of tools. First, let's load a .gprec file to a sensor. Click the Upload Replay File button in the toolbar, located above the data viewer. For this exercise, select GoPxL G2430 GTT02 file previously mentioned. If you haven't already, you will need to have this file downloaded using the link in the video. If prompted, discard or save any unsaved job settings. Note the replay toggle will automatically turn on to view the recorded data in the GPRec file. A surface scan image of a 3D printed target should appear. View the recorded GPRec file. This file contains surface scan data, therefore surface view is the default. Change the view to perspective by clicking on the view icon in the top left corner and select perspective. You should now be able to orbit the image in the data viewer. Try holding the Shift button and orbit using your mouse to pan the view from side to side. Next, change the view to profile and inspect the data. Now, change the view back to surface. Next, let's try adding 3 measurement tools in GoPxL: surface bounding box, surface mask, and surface dimension. Let's navigate to the Tools page. Mouse over the Tools list column on the far left of the screen to expand the panel so you can view the tools' names. Alternatively, you can click the arrow at the top to leave that panel open. Let's use the search function at the top of the Tools column to find the surface bounding box tool more efficiently. Click on the search function input box and input bounding. Scroll down to find the surface bounding box tool, then drag it to the column to the right, or you can also double-click to add. The inputs and outputs will automatically connect. To view these, expand the Gocator 0 panel by double-clicking it or clicking the double arrows in the top right corner. Also, expand the surface bounding box tool panel. Next, let's adjust the bounding box settings to exclude the scan bed, as in that yellow-green turf on the bottom. Ensure that you have selected the bounding box tool by clicking on it in the Tools diagram panel. You will know it is selected when it is highlighted in blue. In the Tools configuration panel on the right, open the Parameters section. Do not check the Enable box under Regions. Instead, we will use the percentile filter by checking the box. Set the high percentile to 100%. Set the low percentile to 5%. You should see the blue or teal region box ignore the lowest 5% of data points on the Z-axis, capturing only the 3D printed target along the Z-axis between the values you set. You can collapse or expand the tool configuration panel by clicking on the arrow or title bar. Go to the Outputs tab down below. Enable the width, length, height, and center point measurements by checking the boxes. Next, find and add the surface mask tool. Same as before, drag it to the right and add it to our tools in use. At the bottom of the window under the Tools panel, click on the Tool Help panel. This describes each tool as well as contains useful information on the details of each tool. Here you can see the Surface Mask tool lets you extract up to 16 regions of data from a surface. For now, we will collapse the Tool Help menu. In the Parameter section under the Regions, select 2 in the Number of Regions drop-down menu. Focus one region of interest box on the peg near the edge of the target, and the other region of interest box on the peg under the letters GTT02. We recommend starting with the surface or top view in the display viewer to adjust your ROI boxes to begin with. Then further adjust the ROI boxes in perspective view. To see the masked regions, expand the Surface Mask Tool panel, and in the Output panel, click on the Uniform Extracted region. In the Surface Mask Tool panel, click on Surface Input, Gocator 0, Gocator 0 Top Surface Uniform to see all scan data. In the Parameter section of the Tools configuration, open the Region Type 1 drop-down menu. Select Circle. Resize the yellow region of interest box to fit the circle around the peg. Open the Region 1 menu by clicking on the blue title. In the inner diameter, input 0 mm to remove the 3 mm cut out of the middle of the extracted region. Finally, let's add the Surface Dimension tool. Find the Surface Dimension tool in the Tools menu either by scrolling or using the search function. Add the Surface Dimension tool to the right under the Surface Mask tool by dragging and dropping or double-clicking. This will automatically use the Surface Mask tool's output as an input for the Surface Dimension tool, meaning that we will only see the masked regions we just made. You will have 2 yellow region of interest boxes. Again, I recommend using the surface or top view to move the boxes at first, as it's easier in 2D space. Move Feature 1 box to capture one of the pegs we previously masked out. Move Feature 2 box to capture the other peg. In the Tool Configurations Output section, you should be able to see the width, length, height, and distance measurements between the 2 pegs. In the Tools Configuration Parameters section, open the Feature 1 Type drop-down menu. Select Max Z to choose the highest data point inside the Feature 1 yellow ROI box. To display the width, length, and height measurement arrows in the data viewer at the same time, you must pin the measurements. To view only the measurements, click on the outputs. In this example, we will pin the width. Click on the Gocator 0 tool panel to see all scan data for the next exercise. Create multiple data viewer windows and views. In the top right-hand corner of the data viewer, click Split Vertical button. You may have to collapse the Tools Configuration panel to view both windows. In the new window, change view to perspective to orbit the target. Let's change the views and modes with the toolbar at the top of the data viewer window. In the new data viewer window on the right, click on the height map icon. Change the view to points mode by clicking on the mode drop-down menu and selecting points. Zoom in on the scan data to see individual data points. Change mode from points back to mesh view. Change view to intensity to see the black and white contrast overlaid over top of the 3D data point cloud. You can also add a new data viewer window external to the GoPxL browser window by clicking on the Pop Out button. Let's pin an output to the new browser window. Navigate back to the GoPxL browser window. At the bottom of the displayed outputs panel, under the data viewer, click on the Pin and Output drop-down menu. Select a measurement output previously set up. For example, let's use surface bounding box length. The surface bounding box length will be pinned in the data viewer and displayed outputs. Alternatively, you can click the pin icon to the left of the displayed outputs panel to pin an item to the data viewer. Because all pop-out and split view data viewers have their own displayed outputs panel and toolbar, you can truly customize your environment. Click on the link icon to the right of the Pin and Output menu to copy displayed outputs for use in GoHMI. Open a new browser window or tab, then paste the link to the browser address to create an additional GoPxL visualizer window. Save your measurement tool configuration as a job file. Click the job list drop-down in the top left corner. Click the Save As button. Enter a name for your job. And click Save. To output these measurements as a Gocator output, please see the next video, Measurement Tool Sample Exercise 2, Multilayer Scan Data from G5000 Sensors. For further assistance, please contact support@lmi3d.com.